Hey guys, Mr. Lauer here. Hope you guys are ready for some new material. Hopefully that test went well for you yesterday. But now we're shifting gears. We're going to be talking about something completely different. So if you didn't like conics, or you hated conics, or you did bad at conics, good news. We're kind of resetting. We're kind of going into another realm, kind of more of a statistical realm. And specifically, we're going to be talking about probability in this chapter, which is chapter 10. And if you want to follow along in your book, we're in section 10.1. We will probably do a homework assignment from 10.1 maybe tomorrow. But we're just going to kind of get some vocabulary down, calculate some basic probabilities here today, and it should be pretty cool. Now the cool thing about probability, the thing that I like about probability, is that we live in an uncertain world. That's pretty clear based on how you're getting this video lesson, right? And we as people don't do well always with ambiguity or with things not being exact, right? We don't do well with uncertainty. And so what we want to do, what our brains try to do, what humans have been trying to do for thousands of years, is to quantify uncertainty, right? There's all kinds of questions. What grade am I going to get? Or will we ever go back to school? Or will that boy I really like ever call me? Right? All kinds of things like that. And it's uncertain. It either happens or it doesn't happen. We either go back to school or we don't. We either get an A or we don't. We either get that call or we don't. But if we can quantify it, put a number to it, understand it better, that kind of helps us psychologically to be able to deal with some uncertainty. Sometimes we can't do that. We just got to deal with it. But in the math sense, we can quantify uncertainty or how likely something is to happen. So let's take a look at a definition here. So probability is a quantitative measurement, which is great. It's a number. It's something we can wrap our heads around. It's a measurement of how likely it is for an event to happen, right? That could be an event, could be like rolling a certain number on a die. It could be like flipping a coin and getting a heads. It could be drawing a card from a deck. It could be something, raining tomorrow or sunshine tomorrow. It could be, getting an A on a test. So some event, right, we want to know how likely that is to happen, okay? And we can sometimes put a number to these things. A probability, important thing to note, it's always a number between 0 and 1. And we'll talk about why that is the case a little bit later. We also can express a probability as a fraction or a decimal or a percent, and we'll see it expressed all different ways, okay? One of the ways we can determine a probability is by doing an experiment. We can figure out something that we want to know a probability about, and then we can set up an experiment and kind of run through it. So we're going to do an experiment. I got a quarter, just a regular quarter, no tricks. I feel like I'm a magician. And what we want to do is maybe just figure out what's the probability of getting a heads, right? So that's an event. The probability of getting a heads would be an event. Okay, so what we're going to do in our experiment is we're going to do some trials, right? A trial is a systematic opportunity for an event to occur, right? So if I want to get a heads, then I need a systematic opportunity to get a heads, which means I'm going to flip it, okay? That's a trial. Me flipping the coin is flipping it to see if I get a heads or a tail. Okay, an experiment is one or more trials, so we'll do it a few times and see what we can come up with. Okay, sample space refers to the different possible outcomes that I could get. So when I flip a coin, what are my possible outcomes? Well, I can get heads or I can get tails. So the sample space for this experiment is heads or tails. What are all the different possibilities I could get? Right? I get heads or tails, that's it. And then an event is an individual outcome. The event we're talking about is flipping a heads, right? We're just flipping a coin, and the one we're specifically looking for is getting heads. We're going to talk about the difference between experimental probability and theoretical probability. Right now, we're just going to kind of calculate an experimental probability. Okay, so those are what those different things mean. Trials is just, in this case, flipping a coin. We're going to do it more than one time. Possibilities are heads or tails, and the event we're looking for is a heads. So what we're going to do is we're going to keep track of the number of trials, and we're also going to keep track of the different outcomes that we could get. Okay, now in this case, we know we could either flip a head, or we could flip tails. We're just going to kind of keep a tally of how many times that happens. Okay, so here we go. Okay, regular quarter. experiment, trial 1. Okay? It was tails. Okay, I got tails. So number of trials, I'm going to put a tally mark here, and it was tails. Okay? Let's try it again. Okay, it was also tails that time. So in these two trials, if I think about these two trials, what's the probability, oops, sorry, I put it in the wrong spot. What's the probability of getting heads? Well, it seems like 0 based on this experiment. I've never gotten heads so far, right? If you were to make a conjecture after 2 trials, you would say it always comes up tails because it's come up tails twice. That might be your conjecture. But we haven't really done enough trials to really think about that, right? So we want to keep going. Right now, though, let's just take a look at this, experimental probability. So we talked about making a conjecture, looking at patterns. If you remember from way back in reasoning, that's inductive reasoning. Okay, we're doing a bunch of trials, we're looking at data, we're observing, and we're going to see if we can see a pattern, okay? The way we get an experimental probability is to just determine how many times did we get the outcome we're looking for over how many trials. So let's go back to this. Sorry, there was 2 there as well. We did 2 trials there. So how many trials did we do? 2. Out of those 2 trials, how many times did we get heads? We got 0. So there's a fraction, right? I could also write this as a number between 0 and 1, like a decimal, or as a percent. Right? So right now, our experimental probability of getting a heads is 0. Okay? Does that make sense? Should we always get tails? Well, if you've ever flipped a coin before, the answer is no, we shouldn't. We should get tails half the time and heads half the time, right? So what's the problem here? The problem here is that we haven't done enough trials. We've only really done 2 trials. So this is kind of a conjecture, or this is kind of an observation that we've made. It's not a very good experiment yet because we've only repeated the experiment twice, or we've only done 2 trials. Okay? So to find experimental probability of something, you have to do the number of times you've gotten that outcome divided by the total number of trials. So let's write that up here. Keep that in mind as we keep going. So the probability of an event. Well, the event in this case is getting a heads. So it's the number of times we got heads divided by the total number of trials. So number of heads, right? Number of times we got heads over number of trials. Okay, let's do a few more. Get out my coin. Okay, here we go. Oh, it's tails again. Wow. Maybe this is a trick coin. I don't know, my wife switched it on me without telling me. Okay, so it looks like, again, it's still, the number of times I got heads was 0, out of the number of trials is 3. It's still 0%, or the likelihood is 0. Okay, that's my experimental probability. Let's keep going. Please heads. Oh my gosh. It's tails again. Okay, so let's keep going. Maybe I'm just flipping it with the same amount of force. I'm going to let it fall far this time. Okay, heads. Okay, so now we've gotten 1 heads for 5 trials. So what's the probability of getting a heads right now after 5 trials? 1 out of 5, right? Which equals 0.2 or 20%. So based on our observations, we expect it's a 20% likelihood. Like what's the possibility? Now it should be more like 50-50, right? We shouldn't get tails 80% of the time. So that's kind of weird. So here's the deal. If I were to flip this more times than we have time for, like 1,000 times, we would expect this to start evening out, right? If I flipped it, 1,000, 10,000, 20,000 times, I would expect that a lot of those start coming up heads, right? It just so happened randomly that I got, a few tails at the beginning. That's okay. But we would expect this to be 50-50, right? So let's talk about a different kind of probability for a second, okay? We're going to talk about theoretical probability, okay? So theoretical probability is more like something that we calculate. And we're going to assume that this coin, the getting heads or tails, is randomized. And what randomized means, random is a really important idea here, is that it's equally likely for me to get heads or tails. So with a regular coin that doesn't have any funky stuff going on, it should be very random when I flip it. That's the idea, is that it's random. And it should be equally likely for me to get heads and tails, which is why we flip coins for like different games and stuff. Okay? So a theoretical probability of an event is written like this. The probability of A. Okay? So we just call the event A, right? The probability of some event, we label it A. It could be anything. It could be probability of flipping a heads, like in this case. Okay, the probability of some event is equal to the number of ways to get that outcome divided by the total number of outcomes. So it's the number of ways for A to happen divided by the size of the sample space. Okay. Now in your book, they say, the top part of this, they say the number of outcomes in A. What that means is basically how many ways are there to happen. So in this case with the coin, there's not more than one way to get a heads. There's only one way, because it's either heads or tails. Okay, so that's kind of strange. But when we talk about cards and dice later, that will make more sense. So if I want the probability of heads, the theoretical probability, which doesn't have anything to do with this experiment I'm talking about, this is just theoretical without doing an experiment at all, then the probability of heads is how many ways are there to get heads by flipping a coin? Well, there's only one. There's only one head, so you get a heads. So there's one way to get heads. Okay, how many different possible outcomes are there? Well, there's two, right? So this idea is the size of the sample space. Sample space is the set of all possible outcomes. How many outcomes are there? There's two. There's two options for you to get. So the probability of getting heads should be about 50%, or about 1/2, or about 0.5. That's what we would expect. Okay? So the theoretical probability is what we arrive at using the idea that things are randomized, equally likely outcomes, and we set up a proportion using like math. Okay? An experimental probability is what we get when we do an experiment. So we got two sides of the table here. We got inductive and deductive reasoning. Okay? Inductive would be experiments, observations, things like that. But you notice it's not always accurate, right? Theoretical, you have to make some assumptions about likelihood. You got to figure out some different things. But the idea is, as the number of trials increases, these should become closer together, right? So, let's say I did 1,000 trials with this coin. And let's say I got heads 490 of those times. So 490 divided by 1,000, right? Well, that would be like 0.49 or 49%. So the idea is, as we increase the number of trials, because I only flipped this coin 5 times, right? So this is not, the 20% that I got is not a very accurate or a very good conjecture. It's not a very good probability, because we didn't do it enough times. In order to get a really good experimental probability, you have to do many, 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 many trials. Like at least 100, but like more than that usually. And what happens is this should get closer to this. The experimental probability should get closer and closer and closer to this theoretical probability.